Now let us start with exercise 6.9.1 in continuation with the previous video. In the previous video we have done the introduction to the applications of trigonometry. Now we start with the exercise 9.1 question number 1 first. The question number 1 says a circus artist is climbing a 20-meter long rope which is tightly stretched and tied from the top of a vertical pole to the ground. So if this is my pole AB, vertical means making 90 degree with the angle, the ground, this is my ground, and AC is the rope. Artist is climbing the rope. Rope is stretched and tied to a point C on the ground. We need to find the height of the pole if the angle made by the rope with the ground is 30 degrees. So this angle with the rope and the ground, between the rope and the ground, is 30 degrees. So I have AB is my pole, AC is rope which is 20 meter long, then angle ACB is 30 degrees. We need to find AB. So in triangle ABC, angle B is 90. I have hypotenuse. This is 20 meter. I have hypotenuse and I need to find out perpendicular. We know the side which contains 90 degree and the angle is the base, right? And the other side is the perpendicular and the side opposite to right angle is the hypotenuse. So I need to have a relationship between perpendicular and hypotenuse. So obviously sine. So sine 30 degrees is perpendicular by hypotenuse. So which is AB by 20. Hypotenuse is 20 here. Sine 30, children, we know is 1 by 2. So is AB by 20. So I get 20 by 2 is AB. So we get AB as 10. Therefore, rope, this is the pole. The height of the pole is 10 meters high. Got it? First question. Now moving on to the second question. The second question says a tree breaks down due to storm and the broken part bends so that the top of the tree touches the ground, making an angle of 30 degree. Let AC be the tree. So this AC is our tree. Then let this be the point where the tree broke. Okay, be this point of breakage. So this part is the broken part and this part is hanging loose. This will fall down. It broke from here and it is falling to the ground. So again this is our broken part. So this is equal. I have AB equal to BP. This is the broken part. AC is my tree and AC is equal to AB plus BC, right? And AB is equal to BP. So can I say the length of the tree is BP plus BC? Now he says this broken part is making an angle of 30 degree with the ground. So this is our ground. It's making 30 degree with the ground. The distance between the foot of the tree to the point where the top touches. The top touches here at this point and the foot of the tree is here. So the distance between this is 8 meter. We need to find the height of the tree. So in order to find the height of the tree, what do I need? I need BC and I need BP. Because BP and BC, this is what I need. Now let's see how can we find out. In triangle BCP, angle C is 90. If this angle is 90, what do we have? In order to find out BC, I know this is perpendicular, this is base, this is hypotenuse. So I need a relationship between perpendicular and base. So tangent 30 gives me that, tangent theta. Tangent 30 is BC by 8, as tangent theta is perpendicular by base. So theta here is 30 degrees, and tangent 30 we know is 1 by root 3 is BC by base, which is 8. So I get BC is my 8 by root 3. Since we do not leave the denominator irrational, so let us rationalize it. After rationalizing, I get this. BC is this. Next, BP we need to find out. So BP, how do we get BP here in this question? BP will get it from, because it's hypotenuse, so I may get it from either the cos or the sine. Okay, so if I use sine, what do I get? Sine 30, if I use cos, because base hai hamare paas, cos 30 will be equal to base, that is 8 by hypotenuse, which is BP. And what is the value of cos 30? Cos 30 is root 3 by 2 is 8 by BP. So we get, children, BP as BP into root 3 is 16. So I get BP as 16 by root 3, which is, if either I rationalize it here, since we need to find out AC, so AC is our BP plus BC. BP was 8 by root 3 and this is 16 by root 3. So I can directly add, it gives me 24 by root 3. Now we can rationalize it. So root 3 by root 3. So this is 24 root 3 by 3, which is 8 root 3. So the height of the tree is 8 root 3 meters. If the value of root 3 given, you substitute, otherwise you leave it in this form. So no need to rationalize here separately, because in the answer we do not leave our denominator irrational. So we had to calculate the total height of the tree, so we will rationalize towards the end, once only towards the end. So once again, here the AC was the tree, B is the point of breakage. So AB part is hanging loose, now it is hanging down and making an angle of 30 degree with the ground. So, and the point where it touches the ground and the foot of the tree, they are at a distance of 8 meters apart. So this distance is 8. So in order to find out the height of the tree, I need to find out AB plus BC is the height of the tree, total tree, and AB is equal to BP. So I need to find out BP, I need to find out BC. Now in this triangle, right triangle, the side containing 90 and the angle is base. The other one is perpendicular and the side opposite to 90 is the hypotenuse. Now I need to find out perpendicular and hypotenuse. So base we have, so tangent theta is perpendicular by base, theta here is 30, so tangent 30 is BC by 8. So I got BC as 8 by root 3. This is my BC, 8 by root 3. We will not rationalize it here because the question needs to be continued further, so we'll do it at the end. Next, I need to find out hypotenuse. So cos 30 is base upon hypotenuse, cos theta is base upon hypotenuse. So I use that, and we got BP as 16 by root 3. Now BP plus BC is AC. So substituted the values. I got denominator same. We added the numerators directly. 24 by root 3. Now rationalized it. We got 8 root 3. So the answer statement is important. The height of the tree is 8 root 3 meters. I hope you understood this question. Now we are moving on to question number 5. Question number 5 says, a kite is flying at a height of 60 meters above the ground. So let's make a ground First of all, this is our ground. Kite is flying at a height of 60 meters above the ground. The string is attached to the kite, is temporarily tied to a point on the ground, and the string is making an angle of 60 degree with the ground. Suppose this is our string. See, this is my kite, a kite. This point is my P, string tied to the ground. This is my ground. This is string. Kite is flying at a height of 60 meters. So this is 60 meters from the ground. We need to find the length of the string. Understood the question? Either you write by the side of the figure or you write it separately, that this is my kite and this is the point of observation and all. So this angle that the string makes with the ground is 60 degrees. Now in triangle ABP, angle B is 90. Now here this is my hypotenuse, this is base and this is perpendicular. We are looking for hypotenuse and I have perpendicular with me. So we will use sine theta. Sine theta we know is perpendicular by hypotenuse and theta here is 60. So sine 60 is 60 by this hypotenuse which is AP. Sine 60 is root 3 by 2 is 60 by AP. So we get AP as 60 into 2 by root 3. So AP is my 120 by root 3. But we do not leave the denominator irrational. So we will rationalize it. So I get AP as 120 root 3 by 3, which is 40 root 3. Therefore, the length of the string is 40 root 3 meters. If the value of root 3 given to you, you substitute, otherwise you leave it like this in the question. Since the value is not given, so we will not substitute. If the value is given, you substitute and calculate, otherwise you leave it in this form. Right? Next question now. Now we will be doing question number 6. Question 6 says, a 1.5 meter tall boy is standing at some distance from a 30 meter tall building. So we have a building which is 30 meter tall and a boy which is 1.5 meter tall is standing at some distance from the building. The angle of elevation from his eyes to the top of the building increases from 30 to 60 as he walks towards the building. Find the distance that he walks towards the building. This is the question. We need to find the distance which he walks towards the building. So first of all, let's make the figure by following the instructions given. What are the instructions? We have a boy which is 1.5 meter tall. Obviously, the boy will be standing on the ground. And I have a building. So let's make this building. This is my building 30 meter. AB. Let's say the height of the boy is given, so we need to consider this height. Let's say this is the height of the boy. So I'll draw a line parallel to this. Now he says angle of elevation from his eyes to the top of the building increases from 30 to 60 as he walks towards the building. So earlier his angle of elevation was 30 degree. Then he walked some distance. Now the angle changes to 60 degree of the building. This is what he says. as we approach towards the object, our the line of sight will be steep, angle of elevation will increase. So this is 60 and this is 30 degrees. This is 1.5 meter. So the height of the boy 1.5 meter. So this distance AP, let's call this S, let's call this T. Right? Now AB is my building. AB is building 30 meter high. Right? This is TL. TL, boy 1.5 meter tall. Okay. Now this is angle of elevation 30 degrees, angle of elevation 60 degree. This is the initial position of the boy and this is after he walked some distance towards the building. This is the another second position of the boy. We need to find the distance he walked towards the building. Let's call this distance X, that he walked towards the building. We need to find out TS, the distance walked towards the building. We need to find out this distance X. Right? And let's call this distance Y. Now in triangle APB, first of all let's find out AB is 30. AB is 30 and what is AB comprising of? AP plus BP is 30. BP is 1.5. So AP plus 1.5 is 30. So my AP is 30 minus 1.5. How much is 30 minus 1.5? 28.5. So this much is 28.5. Let's write this 28.5 meter. Building was complete here. This was 30 meter. Ye 30 meter and this inside is 28.5 meter. Now in this triangle, let's find out this distance. I have angle P is 90. So I have perpendicular. I am interested in finding base. So perpendicular by base is tangent theta. So I have tangent 60 is equal to 28.5 by y. Tangent 60 is root 3 is 28.5 by y. So we have y as 28.5 by root 3. Next, in triangle APT, angle P is 90. We need to find out X. So in this bigger triangle, I have tangent 30 degree is equal to 28.5 by X plus Y. Perpendicular by this base. Tangent 30 is 1 by root 3 is equal to 28.5 by X plus Y. So I get X plus Y is 28.5 into root 3. We are to find the value of X. So I'll put the value of Y, substitute the value of Y here. So Y, we got this X plus 28.5 by root 3 is equal to 28.5 root 3. So I get X as 28.5 root 3 minus this. Can I take 28.5 common? So what I am left with is root 3 minus 1 by root 3. Let us take the LCM. So I get X as 28.5 into root 3 is 3 minus 1 by root 3. So this gives me, let's take another sheet. So I get, let us substitute here. So I get X is equal to 28.5 into 2 by root 3. Now, since denominator is never irrational, we never ever leave the denominator irrational, so I'll have to rationalize it. So I get, multiply kar de first of all, 28.5 into 2 is 57 by root 3. So into root 3 by root 3. This gives me 57 root 3 by 3. So x is, this will cancel,